All right, so our test tomorrow is on 3.1 through 3.4. So the top of the review says you also have to know exponential and log graphs. So just like the quiz and their characteristics, solving using the one-to-one property. So that was when we had like 2 to the power of x is equal to 2 to the power of 3, and you can cancel it out. So solving that way. And interest questions. So our two interest formulas were p times 1 plus r over n to the power of nt. And then the other one was p times e to the power of rt. So make sure you know your interest formulas and how to use them. Then you also need to know two expanding condensed. That's the next part. So I don't think we'll have time to do all of the questions, so I'm going to skip a few because a lot of them are kind of repetitive. So let's look at number 5. And if I skip one that you want to see, I'll go back to it. Just ask. So here I'm dividing. So how would I expand this? Subtraction. So I'd have log of x minus, and every time we break it apart, it needs its own log. So log of y to the 5th power. And what else do I need to do? Move the 5. So that 5 is my exponent, and it just goes right in front of the log that it's attached to. So this would be log of x minus 5 log y. All right, let's look at number 6. So here we're multiplying. What goes with multiplication? Addition. So everything that I'm multiplying here gets broken up with addition. So this would be log of x plus log of y plus what? 2 log z. Awesome. Right, there's one more expanding one that was on the WebAssign that a couple people asked about, which I thought was a good one to look at. So I'm going to write it down here. So ln of the square root of x to the 4th power over y to the 5th power. How can I expand this? What should I do first? Perfect. So I can get rid of that square root and put it to the power of 1/2, because that's the same thing. If I had x, the square root of x, that's the same thing as saying x to the power of 1/2. And we have a power property. So I would like to make it an exponent. That way, what can I do with the exponent? Move it to the front. So that would be 1/2 ln of x to the 4th over y to the 5th. What can I do next? Subtract. So because I'm dividing these two, I can break it up with subtraction. So that would be 1/2 ln of x to the 4th minus, that 1/2 is attached to both of these two things. So it would go with both the ln's when I separate it. So minus 1/2 ln y to the 5th power. And then what can I do next? Move the exponents to the front. What do I do with the exponents that are already in the front? I can multiply them. So 4 times 1/2 would be 2. So 2 ln x minus 5 times 1/2 would just be 5/2 ln y. But WebAssign wrote this answer as 2 ln x minus 5 ln y over 2, which is the same. So these two are the same things. And there's one more that I want to do that was a common question that you guys had from WebAssign. So it was ln of e to the 7th power over 3. How can I expand this? Subtract. So it would be ln of e to the 7th power minus ln of 3. Can I simplify it anymore? How? Ln of e cancels, so it's just 7 minus ln of 3. So let's say I had log base 3 of x over y times z to the 3rd power. how would I expand this? Log 3x minus log 3y. Perfect. Minus 3 log 3z. So both things on the bottom get a minus sign. Like another way to write this would be log base 3x minus log 3y plus 3 log 3z, which is the same thing. Either one of these would be fine. They're the same. So let's take a look at number 8. How can I condense this? Where should I start? Perfect. So the coefficients go up top as exponents. When you're adding, that means we multiply. When you're subtracting, that means you divide that number. Yes. You can also write this as log base 2 of the cubed root of x times y cubed over z to the 7th power. That's fine too. Either way. If you see a question like this, it could also be written as log base 2x over 3, which these two things mean the same. Just a different way of writing the 1/3. Yes. How would I expand number 9? Log base 7, 2 to the 3rd, minus log base 7, x to the 5th. Can I expand this any more? How? Move the exponents to the front. So it'd be 3 log base 7 of 2 minus 5 log base 7 of x. Okay, let's take a look at 11. What do I need to do to solve 11? Perfect. My goal is to get that e to the x all by itself, so I want to move everything else to the other side first. So I'm going to add 14 to both sides. So 3e to the power of x is equal to 25. Then what would I do? Divide by 3. So e to the power of x is equal to 25 over 3. And then what would be next? Take the ln of both sides, because the ln of e cancels. So x is equal to the ln of 25 over 3. And we would just put that in the calculator. And what do we get? 2.12. All right, let's take a look at 12. What do I need to do to solve 12? Add 6. So ln of 3x is equal to 6. What can I do to get rid of that ln? Make the big base e. So e to the power of ln cancels, and I'm left with 3x is equal to e to the 6th power. And then I can find what e to the 6th power is in my calculator and divide both sides by 3. So what do we get for x? $134.47. All right, let's look at 14. So what can I do to solve 14? So I make the big base 3 on both sides. So it'll cancel out with the log base 3. So I have 2x plus 1 is equal to 3 squared. What is 3 squared? 9. And then we just solve for x. So subtract 1 on both sides. So 2x is equal to 8. Divide by 2. So x is equal to 4. All right, let's take a look at 15. What can I do to solve 15? Condense it. So all my properties either have one log on one side or a log on both sides. If I have two logs on one side, I just want to condense it to one. So this would be ln of x over 3. Since we're subtracting, that goes with division. That's equal to 4. How can I get rid of the ln? Make the big base e. So that cancels out with the ln. So x over 3 is equal to e to the 4th power. I'd find out what e to the 4th power is in the calculator, and then what's the last step? Multiply it by 3. So this would be e to the 4th power times 3, which is what? What is it? 163.794. Right, so 20 is another one that we have to factor because it has e to the 2x and e to the x. So how would I factor this? Multiply the first times the last, so we get negative 6. What are two factors of negative 6 that add to negative 5? Negative 6 and 1, awesome. So this would be e to the x minus 6 and e to the x plus 1. What do I have to remember to do next? Divide by 2. So the first one simplifies, so it'd be e to the power of x minus 3. Second one does not, so we move our denominator in front of the e. So 2 e to the power of x plus 1. Then I would set them both equal to 0. And solve them each. So add 3 to both sides. E to the power of x is equal to 3. How would I solve for just x here? Ln both sides. So x is equal to, what's the ln of 3? .099. The second one, we're going to do the same. Subtract 1 on both sides. Divide by 2. So e to the power of x is equal to negative 1/2. I take the ln of both sides. Can I take the ln of negative 1/2? Nope, so it doesn't work. So our only answer is 1.099. So for a log graph, I'll make one up. So let's say we had log base 5 of negative x plus 4. So I have a domain, range, vertical asymptote. Do I have a horizontal asymptote for a log graph? No. So a horizontal asymptote would be none. And then x-intercept. How would I find the vertical asymptote? Set the parentheses equal to 0. So negative x plus 4 is equal to 0. So negative x is equal to negative 4. So x is equal to 4. So my vertical asymptote is x is equal to 4. On my graph, that would be a vertical line through x is 4. To find the x-intercept, we set the whole thing equal to 0. So 0, is equal to log base 5 of negative x plus 4. So then I would rewrite this to solve for x. So that would, I could make the big base 5 on both sides just like I did before. What's 5 to the power of 0? 1. 5 to the power of log base 5 cancels, and I'm just left with negative x plus 4. Subtract 4 on both sides. So this would be negative 3 is equal to negative x, so x is equal to 3. So my x-intercept would be 3, 0. So on my graph, I go to the right 3 and stay at 0. What is my range here? Negative infinity to positive infinity. It's always negative infinity to positive infinity. And then to find our graph, to actually graph it, will help us find the domain because we'll know what direction. Since it's on the left side of the line, it's either going to look like this or it'll look like this. But we know that our domain going from left to right will be negative infinity to the vertical asymptote. So whatever that vertical asymptote is, that repeats in the domain. So it'd be negative infinity to 4. And then we could either plug in points now that we have a calculator to graph this, or we could just know our transformations to know which way our graph is going to go. So because we have a negative on the inside, is that a reflection on the x or the y-axis? Negative on the inside is the y-axis. So our typical log graph would look like this. So if I'm reflecting it on the y, it now looks like this. So it'd go in that direction.
So when you're reflecting on the y, if they're going opposite directions, they don't touch?
Just think about like the y-axis is your mirror now. So however it looks this way, it'll be the same shape that way.
So then when it's reflected on, like when
Let's say my graph looked like my typical graph for a log. Let's say it looked like this, and I had a reflection on the x-axis. So then it would flip along this. This is now my mirror. So it would go this way if I had a reflection on the x, because it would just like, whatever's on top here is now on the bottom. Whatever's on the bottom is now on the top. So this would be a reflection on the x. And that would be if we had a negative outside. So if it was like negative log base 5 of x. Subtract 10. So 6e to the power of 2x minus 11e to the power of x minus 10 is equal to 0. Now what would I do? Perfect. This looks just like a quadratic function. That looks like 6x squared minus 11x minus 10. So we can treat it just as we would with a regular quadratic, but instead of x, we just have e to the power of x. So I'd factor. Since my leading coefficient's not 1, I have to multiply the first times the last. So 6 times negative 10 would be negative 60. What are two factors of negative 60 that add to negative 11? 15 and 4. So it would be negative 15 and positive 4. So that would be e to the x minus 15 and e to the x plus 4. What do I have to remember to do? Divide by 6. Since I started by multiplying that 6, I need to go back in and divide. So divide both the numbers by 6. We can simplify these fractions. So 15 over 6, we can divide them both by 3. So that would be 5 over 2. And I can move the 2 in front of the e. So that would be 2 e to the power of x minus 5. 4 over 6, we can divide them both by 2. So that would be 2 over 3, bless you. Move the 3 in front. So that would be 3 e to the power of x plus 2. What would I do next? Set them both equal to 0, and then we solve. So 2 e to the power of x minus 5 is equal to 0. 3 e to the power of x plus 2 is equal to 0. For the first one, I'd add 5 to both sides and divide by 2. So e to the power of x is equal to 5 over 2. Now, how do I solve for x from here? ln both sides. So if I take the ln of both sides, ln of e cancels, so x is equal to whatever the ln of 5/2 is. What do we get? We take the ln of 5/2. 0.916. Perfect. Now we do the same thing with our second equation here. Subtract 2 on both sides. So 3 e to the power of x is equal to -2. Divide 3. E to the power of x is equal to -2/3. How do I solve for x? Take the ln of both sides. Can I take the ln of -2/3? Nope, you can't take the ln of a negative number, so this is no solution here. It's just not an answer. So our only answer here is 0.916. So what would I need to do to solve for 23? So I have 2 logs on one side and 1 on the other. I know if I have a log is equal to a log, they'll cancel. So how can I make the left side just 1 log? So I can make it log base 7 of 3 times, because we're adding. So 3 times x. That's equal to log base 7 of 32. So what happens to my log base 7s? They cancel. So 3x is equal to 32. Let me just divide both sides by 3. So x is equal to 10.6. Next, let's take a look at 25. What should I do to solve 25? Condense it. Perfect. So I want to condense it to just 1 log. When I'm subtracting, that means I use division. So this would be log base 2 of x plus 5 over x minus 2 is equal to 3. Now how can I get rid of that log? Make the big base 2. So it cancels. So this would be x plus 5 over x minus 2 is equal to 2 to the 3rd power, which would be what? 8. Now how can I solve? I can multiply both sides by x minus 2. That works. So x plus 5 is equal to 8 times x minus 2. We would distribute the 8. So it would be 8x minus 16. And then we would just want to combine our like terms. So we can subtract x on both sides and add 16 to both sides. So 21 is equal to 7x. So x is equal to 3. Bless you. What should I do first for 27? Combine the logs, so I'm going to condense it. So since I'm subtracting, that means I divide. So this would be log of x over 6 is equal to 2 log of 4. What should I do next? Do what? Move the 2. Yeah, before we cancel, we have to move the 2. So this would be log 4 to the power of 2. That's equal to log of 6 over x. Now the logs cancel. So x over 6 is equal to 4 to the 2nd power, which would be 16. And then what's the last step? Multiply by 6. What is 16 times 6? 96. So x is equal to 96. What should I do first for 28? Subtract 5. We want to get that log all by itself. So now I have 1/3 log base 2 of x is equal to 2. What can I do next? I can multiply both sides by 3. That'll work. So times 3 and times 3. So log base 2 of x is equal to 6. What can I do next? Make our big base 2. So it cancels. So x is equal to 2 to the 6th power, which I think is 64. Another way to do this one would be 1/3 log base 2 of x is equal to 2. I think in the answer key, I moved the 1/3 to be the exponent. So log base 2 of x to the 1/3 power is equal to 2. Then I made the big base 2. So it cancels. So x to the 1/3 power is equal to 4. And then how can I get rid of that 1/3? Cube it. I would cube both sides. So raise this to the 3rd power and this to the 3rd power. So those cancel. So x is equal to 4 to the 3rd power, which is 64. So they both work. What should I do first for 30? Condense. So I want to move the 2 on top of the x, and then I'm subtracting, so that means I'm going to divide. So this would be log base 4 of x squared over x minus 1 is equal to 1. What should I do next? Make the big base 4 to cancel out with the log base 4. So x squared over x minus 1 is equal to 4 to the 1st power, which is just 4. What's next? Multiply both sides by x minus 1. So it cancels. So then x squared is equal to 4x minus 4, because I just distributed. What should I do next? You can throw it away. I don't want to square root both sides, because then I still have an x. And there's an x on the right side. Move it over, and then I can see if I can factor. So I'm going to subtract the right side, so minus 4x and plus 4. Just because I like it when my x squared is positive, because it'll make it easier to factor. Now, do I have two factors of 4 that add to negative 4? Negative 2 and negative 2, so x minus 2 and x minus 2 is equal to 0. So what does x equal? 2. So for a question like this, sometimes we may factor and end up with 2 answers. So if this wasn't the same pair, we would have 2 answers. So you'd always want to check your work. Just take your answer and plug it into the x's in here. And make sure whatever you're taking the log of is positive. Because if this was something like 0, let's say I had x is equal to 0, and I plugged it in, this would be 0 minus 1, which would be negative, so 0 wouldn't work as a solution. But here 2 works for both of them.